The title of the selected topic that we have chosen is the application of differentiation in water tank. The problem is about a cylinder tank that the water in it has been polluted and must be reduced until its limit to fill in with the new and cleaner water. And the way the water is being reduced is by running it out through a hole at the bottom of the tank at a constant rate. But our main point of the topic is how to calculate the speed of the water falling from the tank. The details on how to calculate the speed will be discussed later while doing the steps. It will give a better explanation and a clearer view of how we think about the solution and how we try to solve it. So basically, the main way that we use is based on differentiation. But what is exactly the meaning of differentiation? Differentiation in mathematics, process of finding the derivative or rate of change of a function. In contrast, abstract nature of the theory behind it, the practical technique of differentiation can carry out by purely algebraic manipulations using 3 basic derivatives, 4 rules of operation, and a knowledge of how to manipulate functions. In derivative, it is usually used to determine the maximum and the minimum values of particular functions, and especially when modeling the behavior of moving objects. For example, the movement of leaning ladder and an inflated balloon.
So, why we use differentiation? In real life, differentiation are used to calculate a particular question to make new things. Differentiation are also used in other fields, for example, science, engineering, and physics. In math, we use differentiation to find the rate of change of a function. Second, to find increasing and decreasing function. Third, to find tangent and normal to a curve. Fourth, to find minimum and maximum value. Next, Newton's method. Last but not least, linear approximation.
So, our problem is a tank in the shape of a right cylinder has a height of 15 meter and a radius of 7 meter. The water in the tank has been polluted and must be reduced until its limit, which is 1/3 of the tank, to fill in with the new and clean water. The water is being emptied by running it out through a hole at the bottom of the tank at constant rate of 0.5 meter per second. How fast is the water level falling until the tank is at its limit?
As a conclusion, We use differentiation to find out how fast water come out from the tank. We solve the problem by using the formula for related rates. And lastly, we know how fast the water come out from the tank.